Hi, my name is Jeff. I work on Firebase, and in this video, I'll show you how to get started with Firebase AI Logic to bring powerful generative AI features into your web app. My team and I have built a meal planning app that I'm going to use to demonstrate this. It's called Friendly Meals. On the home screen, you see two fields, one where the user can write a list of ingredients that they have at home, and another one where they can specify preferences, like cuisines. In the ingredients input field, I'm going to add a list of ingredients that I know are sitting in my fridge right now. And I'm going to add a note that I'd like to have an Italian recipe for dinner tonight. Now I can click on Generate Recipe, and that will trigger a call to Firebase AI Logic to create a delicious recipe that follows all the specifications written by me. Cool. Now that you're familiar with the app, the next question you might be asking is, what exactly is Firebase AI Logic? Simply put, Firebase AI Logic is a Firebase product that provides access to powerful generative AI models like Gemini and Imagine, which can understand and generate text, images, and more. If you're really familiar with AI SDKs, you might be thinking, that sounds a lot like GenKit. What's the difference? GenKit is designed to run in trusted server environments like Cloud Functions for Firebase or a Firebase app hosting backend. AI Logic, on the other hand, is specifically designed to run on end users' devices. In other words, AI Logic offers client-side SDKs that make it simple to make calls to these models directly from your mobile and web apps. Firebase AI Logic is also designed to keep your app secure, handling things like API key security for you when you use Firebase App Check. If you want to learn more about Firebase AI Logic, what APIs we support, and what you can do with them, watch this video right here. Now, before we can start writing code, there are a few setup steps we'll need to complete. First, we need to make sure we have a Firebase project. I won't cover how to do that in this video, but you can learn how to create a Firebase project and connect a web app to it by checking out our Get Started with Firebase on the Web video, linked in the description below. Now that we have our Firebase project ready and have registered a web app to it, we need to enable Firebase AI Logic for our project. To do so, we navigate to the Firebase AI Logic page and click on Get Started. I'm going to use the Gemini Developer API for this video, which doesn't require upfront payment information. If you choose to use the Vertex AI Gemini API instead, you'll be asked to upgrade your billing plan to Blaze. But don't worry, we won't charge you for anything at this moment. You'll only pay when you start making calls to the API. Take a look at this documentation if you want to understand pricing in more detail. Once you finish enabling Firebase AI Logic in the console, the next step is to add the Firebase AI Logic dependencies to your web app. npm install the Firebase JavaScript SDK and call initialize app like you would for any web app that uses Firebase. In the same place where we initialize the Firebase SDK, we'll import the getAI function and Google AI backend class from the Firebase AI subpackage. Then, we'll call the getAI function and pass in a freshly initialized Google AI backend. Now, we'll export that and can use it anywhere in our front-end code. It's also important to say that if you want to use the Vertex AI Gemini API, you'd import and pass in the Vertex AI backend class instead of the Google AI backend class. And that's it for the setup. Now we're ready to write some JavaScript code and interact with Gemini. First, we'll import getGenerative from the Firebase AI subpackage. We'll call that function and pass in the AI instance we exported from the other file, and also pass in a model name. For this example, I'm using Gemini 2.5 Flash, but you can choose the model that fits your needs best. To learn more about the supported models, take a look at the Firebase documentation, where we explain all models available for various use cases, as well as their quotas and pricing. You can also customize the generation by providing a generation config object for things like temperature or max output tokens, and safety settings to control harmful content. There's even an experimental hybrid AI API that enables you to use on-device models within Chrome, alongside cloud-hosted models. You can see more about that in a Release Notes deep dive video. All these customization options are important, but for this video, we'll keep it simple and stick to defaults. Now we can write a function to generate a recipe from a list of ingredients and user preferences. Since an LLM response takes time to generate, The functions in this SDK return promises, so we'll handle them with async await. It's convenient to start some loading state just before calling the model, await a response, and then remove the loading state. In the context of this app, for example, you want to give the user a visual cue that a recipe is being generated. So here's how we generate a recipe. First, we create a prompt template string and add the list of ingredients typed by the user as placeholders in the template string. Once we have our prompt, we can call model.generateContent and pass the prompt as an argument. And when the model returns the generated recipe, we can read it using response.text, then return that back to whoever called this function in our web app. And there you go. In just a few minutes, we were able to start building with AI with Firebase AI Logic. All of the code you saw in this video is available on GitHub, so definitely check that out. I'll leave the links mentioned in this video in the description below. And if you're interested in adding more AI features to your app, like image generation, bidirectional streaming, and multi-turn chat, subscribe to this channel, as we'll be publishing more Firebase AI Logic tutorials for mobile and web apps soon. Thanks for watching, and happy coding!